In today's video, we will be looking at the Let's Learn the Basics section on page 43 of the SHIN-CHU-MON Mathematics for 8th grade. This is a problem related to speed. We will be finding speed in this problem. Let's begin by reading the question. A boy rides a bike and his older brother jogs on a 4-kilometer road around a lake. If they start at the same point and travel in opposite directions, they will meet 10 minutes later. If they start at the same point and travel in the same direction, after 50 minutes, the boy will catch up with his brother after having completed 1 lap more than him. What are the speeds of the boy and his brother? So in this question, it's asking us to find the speeds of the boy and his brother. So these are unknowns. So let's choose variables to represent these unknowns. So in the case of the boy, let's say that his speed is equal to x. And for his brother, let's say his brother's speed is equal to y. Now, of course, the boy is riding a bicycle and his brother is jogging. It doesn't say who is faster, but we might be able to guess that the boy on the bicycle is probably faster. So let's see how we can relate speed, time, and distance. And the way we can do that is refer to the general formula for speed, time, and distance. So we know that speed times time equals distance. And this is important because we will use this information to write an equation based on the information given in this problem. So it says in the problem, if they start at the same point and travel in opposite directions, they will meet 10 minutes later. So let's see what that means. Here's the boy starting on his bike and he's moving around the lake. And while he is moving around on his bicycle, his brother starts at the same point and is jogging, probably at a slower speed. But since they're moving in opposite directions, they will eventually meet. And let's show that location with a red line. Now, it's not important where they meet. The important thing is they're traveling for 10 minutes before they meet. So we can relate the distance that each one travels and relate that to the total distance that they travel. In this case, the total distance will be the distance around the lake. So you can see the distance the boy travels on his bike is this, and the distance that his brother jogs around is that. So the total distance will be the distance around the lake. So another way to represent that would be if we write distance the boy travels in 10 minutes, and if we add that to the distance that his brother travels in 10 minutes, that will be equal to the total distance around. The total distance around is equal to 4 kilometers. And that, of course, equals 4,000 meters. So let's use meters in this case. So 4,000 meters. That's part 1. So let's label that as 1. So this is 1. And we can write the equation. The distance the boy travels in 10 minutes would be speed times time. So time is 10 minutes times the speed, which is in this case is going to be x for the boy. And then we add the distance traveled by his brother, which is going to be speed times time. So the time is 10 minutes again. and the speed of the brother is y, and that's going to equal 4,000. Now, the second part to this is shown here. It says, if they start at the same point and travel in the same direction, after 50 minutes, the boy will catch up with his brother after having completed one lap more than him. Okay, so let's look at our picture again. Now, coming back to the boy, he's traveling on his bike again, and let's say he's going in a clockwise direction. And as he moves, his brother is jogging. So here's his brother jogging along in the same direction, in a clockwise direction. And as the boy keeps moving around on his bike, he's going faster. So his distance is increasing, the distance between him and his brother. And his brother is coming up from behind, jogging, jogging, jogging. But you can see that the total distance between them is increasing as time goes by. Finally, when the boy continues around, maybe he's coming around on the second lap, his brother is still going along, jogging. At some point, the boy is going to catch up with his brother. And let's just show that with a red line. And again, the location where he catches the brother is not important, but what is important is that he has completed one lap more than him. So one lap means one time around the lake. One time around is one lap. So one time around, the distance is going to be 4,000 meters. In this case, it's going to be the distance the boy travels in 50 minutes. And it's going to be the distance the brother travels in 50 minutes. In this case, it's the difference. So because of the difference, it's going to be a subtraction operation. And the difference is 4,000 meters again. So we can write this as 50x minus 50y equals 4,000. So let's write that again down here. The first equation is 10x plus 10y equals 4,000. And we have 50x minus 50y equals 4,000. These are the simultaneous equations that we need to solve. So let's do that by using the substitution method. So in the substitution method, we need to solve for one of the variables. So let's take the second equation, 50x minus 50y equals 4,000. If we divide 50 by both sides, we will get x minus y equals 80. Then x equals y plus 80. If we take this and we put it into first equation, we would have 10 times x. So in this case, x is equal to y plus 80 plus 10y equals 4,000. This becomes 10y plus 800 plus 10y equals 4,000. Combined terms, 20y equals 3,200. Y equals 160. Now since y equals 160, we can put that into the equation here at the bottom. And then x equals 160 plus 80 equals 240. So we have y equals 160 and we have x equals 240. But what are the units here? Well, remember, x and y are speed. And the units for speed in this case is distance per unit time. And the distance that we're using, the units for distance are meters, and units for time are minutes. So we could say, in this case, speed of the boy equals x, which is 240 meters per minute. And the speed of his brother is equal to y, which in this case is 160 meters per minute. And that is the answer to our question.